So our guest tonight on our Skype connection, which we're glad to have, which we were worried about a little earlier, is Emmett Hohensee. Did I pronounce your last name correctly?
Yep, you did good.
All right, I did good so far. And he is the chief engineer and sales representative for Radiowavz, and that's with a Z on the end, I believe. And it is the hexbeam manufacturer, and again, for those of you that know what a hexbeam is, and again, he's going to explain a little bit more about that as we move along here in the product line. I was just telling Emmett that I built a hexbeam about 6 years ago for our club in Minnesota, and it worked extremely well. It is a dipole antenna, but it's got a directive antenna. It's got good front to back, but I recommend hex beams all the time, and I have a log periodic. So I mean, but if I had a second place, I'd put a hex beam up in a heartbeat. They're an amazing performing antenna. If you talk to people with hex beams, they blow you away. So I'm going to turn over to Emmett, give us a little history of the company, and this company does some amazing things. I've never seen hex beams. I've heard of the 4-band, 3-band, maybe 5 or 6 band. They go all the way down to 160, which is just unbelievable. So I asked Emmett to explain it to me, how you managed that one on a hex beam. So he's going to explain the real low band stuff and putting it on a hex beam. So go ahead and take it, Emmett.
Well, thank you very much. I see Ray in the front there, staring at me. No, just kidding. He's giving me the evil eye, which he's always given me for all the years. Thank you very much for inviting me to your club meeting. Ray's talked about you guys. Gosh, I think just about every time we've gone up to the AES Superfest, and it's been we always kind of wanted to check in with you, but I really appreciate you inviting us to be with you here tonight. Radiowavz started around 1998. Believe it or not, its beginning started with a couple of hams that needed some antennas, and I just happened to be the chief engineer for a radio station up in Omaha, Nebraska, and I built it for them. And I've built antennas all my life, effectively. My first antenna I built when I was about 8 years old. My first radio was a cat whisker radio because I wanted to listen to, of all things, the Omaha Royals play baseball. I loved baseball, and Omaha Royals was my favorite team at that time. So I built a nice little AM radio for listening to the Omaha Royals, and what I discovered with that antenna and that radio was that there was so much more out there. There was a world of stuff going on out there, and I just got the bug from there. So I got my amateur radio license when I was 8, and the rest is histoire, as they might say. Radiowavz, like I said, has been around since about 1998. The business really didn't kick off till around a little bit after 2000, after I lost my full-time job to all kinds of wild and craziness going on with the market. It was just good that I was actually building antennas for people, and we decided to go ahead and make this a full-time business. And one of the few things that you'll discover, that you'll learn about our company, is that we do this for a living. We don't do this as a hobby. We don't just order up a whole bunch of stuff and then build it up on the weekends. Normally, when you call, someone will generally answer the phone. When I say that, I mean, we're not a lot of people, but we try to get to the phone, and we do return our calls, which is kind of neat. And we do try and help in the air, which is one of the things that we really discovered is lacking in our industry, is that there aren't a lot of people that will actually answer the phone and talk to you and try and help you out. And I can't begin to tell you how many phone calls we get on a weekly basis helping them out with someone else's product. But that's just who we are. Because we know that eventually when they need to replace that antenna, be it from hurricane, winds, whatever, 2 trees pulling it apart, they'll probably end up coming back to us, which that's kind of a cool thing. But the thing that we're going to be talking about tonight would be the Radiowavz hex beam. A little quick history about the hex beam in our company. Originally, George, he was the head purchasing agent for HRO. He's a real good friend of mine. Approached me on, "Hey Emmett, you should look at these hex beams. You should start building them." And I go, "George, I don't build beams. I build wire antennas, and that's what we do. We focus on wire antennas." And he says, "Emmett, I really think you should start looking at this. And so basically I just started playing around with the idea, and I started looking at the background of the design. If any of you know Rochelle, she'll tell you that I generally, before I get into a product, before we even build a product, I have to know the product. I have to know, what is it good for, what is it bad for, the ins, the gazindas, and the gazoutas, if you understand what I'm saying. And the hex beam to me was kind of a, how do I say it? It was, I looked at it and I'm going, how in this world does this thing really work? And it was kind of funny because, as I started building them, it's like, holy cow, this is cool. And then I started doing my testing, and I discovered that, I can do a lot with a little. And as we, continue to build our product line, one of the things that continue to hit us on a regular basis is, hey, can you build a hex beam? And I'm thinking, well, I've been playing with it, the hub designs and all that. And our thing is I don't like going to Home Depot or Lowe's and all these other places to buy parts to build our antennas. So generally, I like to build the part for the specific function. And needless to say, it over about 5 years of playing with the product, we finally introduced the product about 4 years ago. And it's been improving and moving ever since. It's been fun. I can't begin to tell you the anecdotal stories already from all the antennas that we've got out there about how nicely the hex beam is performed. Okay, what I'm going to do now is I am going to share my screen with you, and we're going to start our PowerPoint presentation. I don't know, is my face still on the screen?
Yeah, you're still there. Yeah, you're in the corner. There you are.
Oh. Okay, interesting thing about the hex beam. One question that someone had just in the beginning is there's one thing that I think if any of you went to the AES Superfest, I did a series on, it's time to start thinking outside of the shack. In many cases, most of us spend most of our money on the inside of the shack, and that's because that's what's right in front of us. That's something that we can immediately work on and fix, or do something with. And we rarely spend a lot of time thinking about what's going on outside of the shack. And something like the hex beam is one of those antennas where, yeah, this is outside of the shack, and it's kind of cool that you're starting to think this way, because believe it or not, even though a simple 20-meter dipole antenna will do good on 20, it may not do well on 40 or 80 or these other frequencies. So what we've got with the hex beam is an antenna that works on multiple frequencies. But anyway, over here on the left-hand side of the picture, this is the main, the center post of the Sentinel arc. And someone had asked about the feeds and stuff like that. What you'll see is our top there's a feed. Down below there's another feed, and right behind that is our broadband. And we'll get into that in just a few minutes. I just wanted to let you see that picture. Okay, come on. There we go. Okay, and needless to say, the other thing I like about the hex beam is, in my mind, the hex beam is a work of art. Honestly, it's symmetrical, it's easy to work with. There's not much to go wrong once you get it up and running. And in many cases, it's nails on. As far as when you set it up, it works, and you don't have to do any tuning on it. We've actually gotten to the point now with our hex beam that rarely does anyone ever have to do any tuning on it. They just put it together. And it works right out of the box. And pretty much a good demonstration of it was during Dayton when we set up our 40-meter hex beam and a 20-meter hex beam as the main antennas. If any of you who all went to Dayton, raise your hand. I know Ray didn't go. Okay, you're not raising your hands. I saw one hand there. Okay. Anyway, the Sentinel hex beam series. Okay. What is the hex beam? Okay, by the way, if you haven't missed it, that's my dog down there, Zoe. She generally goes with me just about everywhere I go. It's been amazing how these antennas work and where they work. You'll notice that this antenna is in this guy's backyard. We'll fill this in a little bit. What is a hex beam? By the way, this antenna you're looking at right now is our Barrett. Hex beam is basically a 2-element Yagi in the shape of a W. Now, what do you get when you have a W-shaped antenna? Well, it takes up less space. It's more compact, and in this case, it was a lot more symmetrical. So what is a hex beam? Well, what we need to do is let's kind of explore a little bit how we got to the hex beam shape. It all started with the Yagi. Basically, oh gosh, it didn't show up at the top there. Basically, that's a Yagi up above that, so you have a 2-element. Now, the nice thing about the Yagis, it's a nice straightforward beam antenna. Yagi designed it to where it's almost like imagine a laser beam. You're shooting it in the direction you want to go. It's a very tight signal. You're putting your energy. Excuse me. The idea behind the Yagi wasn't necessarily to give you that laser beam, but the whole idea was to put more energy in the direction of where you want people to hear you, and also be able enable you to hear a little bit more efficiently. But it started with the Yagi, but it seemed to take up a little too much room. So here comes Mr. Moxon. Moxon came up with an excellent idea of reducing the size of a Yagi and the overall space required to set up a Yagi. And what he did is he found out that by folding a percentage of the legs, both the reflector and the director, or the driver and the reflector, and spacing them at a specific location, he was able to basically achieve a lot of the same signal strength and characteristics of a Yagi in a smaller space. As a matter of fact, you'll notice that there's quite a few different manufacturers out there, Spider Beam, that basically that's what it is. It's a Moxon. The nice thing about the Moxon is it has some good gain. It has really good directivity, but the problem is it's still a little bit too big. But I think we can do better, Mr. Moxon. How about a reflected M? What we're doing now is you're looking at ways that people have come up with basically shrinking an antenna by just bending the wire. And what happens when you have a director, or let's just say the driving element and a reflector, and you put them in close proximity to each other, you still can achieve a lot of the reflected signal going in the direction that you want to go without losing the gain. There's still you still don't have the gain of a full 2-element Yagi, but you still have directivity. You have the key thing in many cases is you're able to cancel out the noise behind you. So now we've got the reflected W. Okay, that is what we now commonly call the hex beam. Traffic for many years, and he no longer does business. This is basically his design. He was a pioneer of how it was designed. It does a really good job of reducing the space even more than what you would expect from, not just the side, the lengths on the side, but the front and back. As far as, instead of going 16.5 feet on a boom, you're only having to do 10. Makes a big difference. So now, let's look at the Sentinel, what we've gone with. Basically, we decided that by going with the W, the W configuration, it's kind of nice, but you have peaks. In other words, what you end up doing is you have to fiddle with the antenna a little bit to get it to peak right at around where you want it to go, and that's kind of nice. But in many cases, people don't want to have to mess with that. So by moving the back section of the reflector wire out, we discovered that, not us, it was discovered that you get a little bit more, make the antenna a little bit more broad-banded. You don't have as much directivity, but you do have a good front to back ratio. And this is the design that we decided to go with instead of your normal hex beam design, which was that W configuration. And so as you can see, and can you guys see my pointer at all?
Yeah.
Yes.
Okay. You've got the feed point, which is in the center. You've got the direction. You see there's no wires there at all, okay? Then you have what's called tip spacers, and all that is just a rope that, for instance, over here on this side of the hex beam, you can kind of see that. What that is, a rope with two insulators that basically create a separation between the reflector and the driver, okay? Now what happens is this, believe it or not, is critical to a certain extent. If you move this away a little bit, the impedance will change. If you move it too close, the impedance will change. And you'll also notice that the overall bandwidth of the antenna is considerably tighter. So what is the hex beam? Here we go. This is our 20-meter hex beam with another element that we added on. One of the things that we do is we build antennas for the government. We build folded terminated dipoles. And we also build a lot of other antennas specifically for the government. And one of the things that a lot of people told us back when we first introduced our first Sentinel was, man, it would be nice if you could do 40 meters, or it would be nice at 80 meters. Well, a lot of people don't have, 40 feet to work with, but they have 21 feet to work with. So what we did is we came up with, originally, the idea was to just create this big loop around the outside perimeter of the antenna and then create a totally separate antenna. And what we found out over time in playing with it is if I put the antenna, this is actually a terminated loop antenna, and I bend it in the shape of a figure 8, okay, or a pennant, I'm able to create a rotatable dipole, or something that would act like a rotatable dipole, with all the benefits of it being, a quiet loop type antenna, all in a 21-foot space. What this basically does is it basically goes out, comes back. If you can see my cursor, goes out, comes back again. In the middle, there's a terminator and a balun, and then it goes back and it comes back this way. So it creates a figure 8. And what basically happens now is you have it acts like a rotatable dipole because one side is out of phase of the other. So now you have a null, which gives you the ability to rotate the antenna. And because it's a broadband antenna, yes, it's not as efficient as, let's say, a full-size 40-meter antenna and even an 80-meter antenna. But what the advantages you have with doing something like this is, in many cases, you're putting this on top of a tower. And you can't normally go out and rotate your dipole, your 80-meter dipole, on a rotator, but what you can do is you can do this on a hex beam. And the other thing we discovered about it too, by it being so broadbanded, is that it gives you a lot of other abilities to listen to stuff that you wouldn't normally be able to listen to, which there are a lot of people, especially with like the Flex radios and the Anons and all the other SDR type radios, that really like this because they can turn, they have a separate feed, and they're able to look at other things going on in other places without having to change the bands, which is kind of nice. Here's our 40-meter antenna, the same thing. It's just that over time, there was enough people basically told us, well, can you do a 40-meter? Man, if you could only do a 40-meter. And the thing I looked at, it was pretty much not a mechanical nightmare, but it's one of those things that there's a lot of stress, there's a lot of structure to the antenna. And what we have to do is design it where it can withstand the winds and everything else and still not go overboard as far as its weight. Now imagine this is a 40-meter 2-element beam in a 42-foot space. To me, that's kind of a cool thing, don't you think? As you can see here, we also have the broadband element, and we go all the way up to 160 on this one. You can do 160 on the 20-meter, but honestly, you're going to be really lucky to get out because they're just, the antenna, that loop is so small. It's so inefficient at that low frequency, it's going to be hard to get anything done. But on 80 meters, on 60 meters, on 30 meters, this antenna really performs well, especially on 30 meters because it's definitely larger than, well, it's basically the size of a half-wave loop, effectively, on 30 meters. So that kind of makes it nice than 60 meters and so on. Of course, you can see where we've got the spreaders, the spacers, you got the reflector, you got the driver, you got the big open space, which this is the direction of radiation. That's kind of a side profile of it. Nice little simple diagram. Looks like a wine glass. You've seen it everywhere. A little 3D modeling. One of the things that we also did before, this is a real photograph, by the way. This was out at Dallas. It was kind of cool. The sun was coming out, it was raining, and all of a sudden the rays hit the antenna. It's like, oh my. But the interesting thing is that oh man, I forgot what I was going to say. Sorry about that. Ray, what was I going to say?
I don't know. Check your notes. Check your notes.
Anyway.
Let's back up. You're doing fine.
Yeah. Well, we were talking about the 40 meter, and the 40 meter, the nice thing about it is that having a directional antenna on 40 meters in bad conditions is a phenomenal thing. The one thing we're going to start talking about now is how does this antenna perform? Now understand that I'm giving you the information for the 20 meter antenna, but if you multiply that, if you go and apply this, you look at the 40 meter, the data is the same. It's just that it's bigger. In other words, the 20 meter hex beam is about 20 feet. The 40 meter hex beam is 40 feet. And oh, by the way, yes, I do have an 80 meter design on the board, a real one for someone in the Middle East. And that's going to be an interesting design. Okay, there you go. As you can see, it has a nice little toroid pattern. The red line is basically what it looks like, if you were looking up from the sky, looking down, okay? So you have a nice little forward egg type pattern. You've got about 45 degrees to 90 degrees to work with. And then you see this takeoff angle. It can be anywhere between 60 and between 60 and 45 degrees, which is not too stinking bad, considering we're only 32 feet off the ground. The gain isn't too bad either. You're looking at about anywhere between 7 to 9 to 8 dB gain. It does depend on your ground. If you don't have a ground, like you're way up in the sky, obviously your gain goes up considerably because you're above one wavelength from the ground. So that's one of the reasons why you've got this little lobe right here, is because of the ground effect. And as you go up higher, this changes. This gives you another idea of how it looks with, from a wire reference or wire frame. It's a fun antenna to model. Trust me, the models that you see on the internet today, I don't know how they did it. Oh yeah, that reminds me. One of the things that we did do before we actually got into actual manufacturing the antenna is my son in Montana, who's currently stationed someplace else in the world. He was studying, mechanical engineering, and one of the things that he was doing for one of his classes was he modeled our hex beam for us in it's called AutoCAD Invent, which allows you to simulate, natural stresses, motions, movements, and all that. So we were able to build the hex beam in a virtual reality environment mechanically before we built it in real life. And by doing that, it helped us to come up with new and better ways to build the individual components. And because we did it the way we did, the whole antenna weighs 19 pounds. There you go. There's a little bit better diagram. There you go.
Is that for the 20 meter?
Yep. Looks like Teddy's nose on a Friday night. Anyway. What do we get when we were just looking at the hex beam, the 6-band hex beam? You've got 6 bands. You can operate full power, and the nice thing about it is the antenna is resonant on the frequency, and it generally covers the entire band. One feed point on the 20 meter, meaning that you go from 20 meters to 6 meters. You have an 11-foot turning radius. On the 40 meter hex beam, it's a 20-foot turning radius. On the 40 meter hex beam, you've got 6 bands, but you've got 5 bands, which are 20 through 10, has its own feed. 40 meters has its own feed as well. Why do we do that? Because 17 does not get along with 40. And we decided, instead of messing around with an impedance or a matching system that would, make everyone go bonkers, let's just go ahead and keep them separate. And it turns out that it makes the 40 meter element, an absolute, fantastic performer. We've got one customer who...
What do you got in there, bud?
Oh yeah, man. We've got one customer who is a serious RTTY contester, and since he started using the Sentinel hex beam, he's placed so much better than he's ever placed before. He's able to do things that he has not been able to do before going RTTY. And yes, Riddy at 1500 watts is a screamer. We do suggest if you're a serious contester on Riddy, there's a different configuration for this antenna for you because you're looking at 100% duty cycle at 1500 watts. Yes, he does run it at that power, and it's scary, but it works. To give you an idea of some of the gains, you got a 6 dBi forward gain. Actually, it's anywhere between 7 and 8. You got a 20 dB front to back ratio, which is not bad at all. The nice thing about this, I've got a video on YouTube where if you go to our website or our YouTube channel, it'll play it for you, and it shows the antenna pointing towards Texas, and it's picking up 14300, which is the Maritime Mobile Net. I rotate around, the guy goes completely away. And then as I start coming back around again, you can start hearing him again. Excellent demonstration. Another video we've got is where the hex beam is pointing at a noisy transformer. And we rotate the antenna around, and next thing we know, the noise is gone, which is sweet. The other big advantage of the antenna, including the 40 meter antenna, this is only 30% smaller than a dipole. Now imagine this, a normal dipole, a 40 meter beam is literally 66 feet wide. The boom is around 33 feet. So that's huge. The hex beam itself is only 40 feet totally from end to end. It's basically a 20-foot turning radius. Yes, it does have multiple feeds, but we have found that having those multiple feeds gives us a little bit better isolation, and also it gives you a lot better performance, especially on the 40 meter. Band conditions were horrendous at Dayton, but yet literally the world heard us on 40 meters and 20 meters because we were able to have such a good performing antenna, and we pointed in the direction that we wanted to talk, and next thing you know, we were there. Can you guys hear that?
Mm-hmm.
Wow, little.
Light.
3 feet off the ground. Huh? Good, Jack. No hold on.
With that tight, you can hear your clothes on
Basically, here we go. All right, can you hear this? This is the Maritime Mobile Net. Oh, that didn't go far enough, I'm sorry. But basically in the beginning you could hear, okay, this is me doing an end-to setup. It's not that hard. And I do have a supervisor, so I'm being watched.
I see her.
I do not move this fast in real life. This was for the ham radio outlet grand opening in Plano, Texas.
Emmett, while that's rotating, can I ask a quick question?
Yeah.
You said it has multiple feed points. Can you operate 2 different radios on each feed point and work separately?
Well, what's really cool is on the 40 meter, yes. If you had like a bandpass filter for 40 meters, yeah, you could do 40 and 20 at the same time. Interesting thing that we did during the field day is I had a 3-band bandpass filter a 20, 15, and a 10-meter bandpass filter and combiner, and we had 3 radios running off the same hex beam. As a matter of fact, at the ICOM field day event station, that's what they did as well. They had a combiner hooked up to the hex beam, and they had 3 7300s running off the hex beam.
Wow. Hey, Emmett, you got separate feed lines running down to the shack, right?
On the 40 meter, yes, or when you're using, for instance, the broadband, and on the 40 meter, a separate feed for the 40, because who's that old guy right there? See how everyone, they all look, they want to give you suggestions. There's Eddie in the background. You know who that guy is back there, right, Ray?
Oh, Dennis.
Yeah, so you have separate feeds for 40, and the reason for that is that 40 and 17 do not get along well together, and it's just much better just to stay with a separate feed. And at first people kind of gawked at the idea of having 2 pieces of coax at the same time coming down, and then the ones who started using it saying, oh man, it makes a big difference when it comes to performance.
How about a switch box up there? Will that work?
We've discovered that it's better to bring the coax down. For whatever reason, the grounds sometimes get screwed up as far as the way it goes from between the 2 different feed points, and what we prefer is bring it all the way down and then do your switch.
Okay.
In this design, you'll see that what I did is I put this tape right here just because I was demonstrating to people that everything's color coded and everything is designed, in other words, you just hook up blue to blue, yellow to yellow, white to white, green to green, and so on. That's Colorado helping me out, by the way.
Do you have any customers in Snowbelt at all that have experiences with this thing in heavy snowstorms, ice storms?
How does Alaska sound?
Sounds like it's really cold.
It's cold and snowstorms and a lot of ice, yes. And like I said, on our 40 meter version, we've got one situation where I've got one in South Dakota. He regularly has 90-mile-an-hour winds. And then in the wintertime, you're looking at icing and everything else, so it survives that, so it does well.
So what's 1 or 2 of the problems you ran into fabricating this design? Did you have some things you had to seriously go back and look at for strength and reliability?
Well, before we even let it out, like I said, we spent a lot of time on the computer simulating the design. We determined that, for instance, the hub design, that from what everyone was doing based on the recipe that you saw on the internet, that hub, my arrow, yeah, there you go. See where my hand is right here? Mm-hmm. This hub, this pole literally goes the entire length, all the way down to right about here. And we're actually using part of the mast, actually goes all the way up to about this point right here on the hex beam, just so it gives you that added support. The area of failure on this antenna, from the other designs, was right there at the hub. It would literally, the wind would blow and it would separate. Now that's the owner of HRO right there. He's picking up the hex beam and discovering it's, there's no weight to this antenna at all. So what we discovered was that things failed right there at the hub, and every pitch I've ever seen of hex beams that have failed from other manufacturers, that was one of the big places beyond the fiberglass itself snapping, because it was underrated. That was the area that we saw that it failed. So by putting the pole, literally your mast goes up about this high into the antenna itself. So it literally gives you that little extra support. So if this antenna breaks right about here, your mast is going to break too.
So on the spreaders, again, there's the fiberglass spreaders. When you're down, like say in Florida or the Caribbean, you've got a lot of UV rays stuff down there. How long do you anticipate those surviving?
The one thing that we determined is that we do shoot the fiberglass with a UV coating, so it's a clear coat. We do recommend that you spray paint the antenna when we're done. As a matter of fact, the center pole right here is primed. You know, we shoot it with a primer, so that way when you get it all put together, just go ahead and spray paint it. It'll protect things a lot better. You know, a lot of people say, well, I don't want to have to paint it, you know, blah, blah, blah. Well, the reality is it'll make the antenna last a lot longer. You know, even with the coat that we put on there, it's, you know, the sun is going to get it, and there's not much you can do to protect it, just short of putting one more coat on there, and it'll last a lot longer.
A reflective paint?
Yeah, like a
silver metallic.
Something with a heavy metal flake.
Guaranteed not to work if you do.
Yeah, pretty much. Now, the
Question,
one thing yeah, go ahead.
what do you guys make the center hub out of? What kind of material?
It's a CPVC and a composite material as well.
Okay,
We cut everything out on a CNC machine, not PVC, CPVC.
yeah,
This is the stuff that costs like about $1,200 to $1,800 a sheet. Well, the idea is that it's supposed to handle low temperatures. It's supposed to be flexible, durable, and so that's the way we build it. And then we put a small layer. It's like a fiberglass type material in between the layers that gets melded inside of all that too. So what happens is you got something that's very strong and very flexible. And as you can see, one of my favorite shots of the antenna right here is at night. And right here you can see this yellow wire right here. That's the broadband antenna. You see it comes up here. This is just a support wire. That's a support wire. Okay, it comes down, goes all the way down, back to the broadband unit, which is on the other side, which is a separate feed. This is on a 20-meter antenna. And the antenna, because it is symmetrical, doesn't require a big rotator. We've got a lot of people right now that are using a simple TV rotator on their a regular heavy-duty TV rotator. This rotator that you're seeing right here is the Yaesu GS450. We recommend the 800 for the 40-meter, just because it's a little bit bigger and it has a better brake on it. So anyway, that's our Sentinel. Now, what's new? We've got we call the Radiowavz Scout. Do you want to hear anything more about it?
Oh, yeah.
This really isn't a beam, but it's we designed it originally for. Well, anyway, let me just it's a 20-meter through 10-meter antenna. We do have a 6-meter element, and I'm in the process of beta testing a 40-meter element that goes outside, and basically a 1 more foot element. So you can do 40 meters on it as well. It's omnidirectional, and it's horizontally polarized. And it's only 8 feet wide, and it has the gain of a dipole. Now, you're going to probably say, well, it only has the gain of a dipole, but it's only 8 feet wide. It fits in your attic. I already asked you that. I kind of, there, oops. Let me go back.
There you go, Lloyd. Just go up.
Sorry. Okay, now what you can see is you got the, well, let me go back one more slide so I can go over the antenna a little bit with you. You got a balun right back here, this section right here. Oh, stop it. It's supposed to, there you go, highlighter. There we go. Okay, right back here you have our balun. Okay, you've got, for instance, this is the 20-meter element. It just comes out, around to this point. And what right here, at this location, it is basically just a simple separator, like about 3 to 4 inches. And what that is that's basically a rope. What that does is it gives you the separation. Now, what happens when you bend a dipole like this? It has a tendency of how do I say this? Here we go. It has a tendency of the impedance goes down to about 23 ohms. For instance, and what you're looking at right here, this is the actual, whoops, this is the actual signal pattern. You can see it's like a nice flat egg, just kind of nice. Well, I kind of like this. Anyway, it has the gain of a dipole. Now, what happens with a dipole when you have it sticking straight out? You'll discover that it has a bean shape and it has a lot of the energy going straight up in the air. Having this antenna horizontally polarized gives us the ability. You see this? We don't have a lot of energy going straight up and down, okay? It's going out to the horizon, just like this, which is what we want. And you're looking at about, 60 degrees to 40 degrees. Not that bad as far as hitting the horizon. So what happens with this is you're now seeing an antenna that when you have it set up, you just stick it up in the air and you can hear a lot. A good example was just recently we did a show, not a show, but a special event with the USS Batfish, which was the submarine. We literally got there, we were waiting for the tower truck to show up, so we went ahead and just popped the antenna up about 30 feet in the air with a push-up pole. And the first contact was Venezuela. If you're asking about what the SWRs are, there you go. This is that's 20 meters, so you see it's below 1.5 to 1. And this was at about 15 to 20 feet. These dips will get bigger as you go higher in the air. So that's not too stinking bad when it comes to SWRs and just getting it right there. And that's just literally sticking it on the pole. Putting the wires together takes about 10 minutes and it's done. Anyway, thank you for your time, and do you have questions?
Okay, questions from the group. Just a quick question, Emmett, from my standpoint. Let's say the 20-meter antenna or the 5 or 6 band antenna. What kind of price point do we talk about in those particular antennas? And then the Scout, what would that run somebody if they're looking to get into that kind of an antenna?
Okay, the Scout is really simple. That one's about $285. It's pretty much ready to play the minute you get it. So you're just like with the hexbeam. We took a lot of what we did with the hexbeam and put it into the Scout. So we built so many of these stinking things that we figured out about where everything needs to be. So we literally, instead of using a wire measuring device, we literally have a standard or a jig that literally, you pull the wire to this point and you cut it here and you strip it here. So that way every time we pull a wire, it's exactly the same. And so for instance, the Scout, which is kind of nice, that thing only weighs 10 pounds. You can pretty much put it in your car. It's only 4 feet long as far as the longest piece. It doesn't take much for it to, oops, trying to get out of my, come on, sorry, there we go. Trying to pull up some of my pictures here for you. I'm trying to pull up a couple pictures to show you real quick. But anyway, with the Scout, $285. The idea is that you want to just take it somewhere, set it up, and it works. And that's what makes it so nice. You're looking at about $650, but there are many different variations of that. Just the 20 meter through 6 meter antenna is $650, and it's ready to play for the most part right out of the box. The nice thing about that antenna is that, like I said, everything's been pre-measured. We pretty much know where everything's supposed to go based on, we've done it about 100 times. And in the beginning, before we shipped the antenna, we actually put it together and tested it. So for the first couple hundred antennas, that was a lot of work that we put into making sure everything was right. And then we tweaked our, the assembly line and all that just to make sure all the pieces and the parts got where they were supposed to go. I'm just trying to find, am I still sharing my screen or do you just see my ugly face?
Just your ugly face.
Oh, yeah. Okay, here we go. Let me see if I can, I'm going to try and pull up this other picture real quick. Okay, here's our standard, whoop, darn it. There we go, let's try and zoom in a little bit. Now one of the things that you can see here, this is our 40 meter hex beam. This is our broadband adapter. I know it starts looking a little busy after a while. That's the broadband element, okay? Then up above that, we actually, for specific customers, we actually make an outrigger or a special rider pole so that you can literally put your 2-meter antenna, or not a big one, but a 2-meter 440 antenna on top of that. So that kind of makes it nice. So you've got another feed going down, and then on the other side, let me see if I can zoom in on this a little bit better for you. Right there, you see that's the feed for 20 meters through 10 meters. Okay, and then above that, right here is the feed point for 40 meters. Which is kind of cool. Then that's the Yaesu GS 800 rotator. And that unit, stop sharing. Oh, no. I cancel. I'm gonna get things working right here. I'm on a different computer, so it's, there we go. I'm used to having almost like my own, I have like F keys all programmed in and all that. But the hex beam, the Sentinel itself, the Barrett, the 40-meter unit, which is 40 meters to start, it's a 40 meter, and then a 10 meter through, or excuse me, a 20 meter through 10. That runs around 1,500. Now you're going to probably, don't 100% quote me on that one because I get in so much trouble sometimes when it comes to pricing. That's why I always leave it to Rochelle. I'm just the mere engineer. She's the one who understands all the pricing. And then adding on the broadband elements, that generally adds on anywhere between $175 to $250, depending on the power requirements that you want. We do make them at different power levels. Obviously, to begin with, handles about 500 watts. After that, we go all the way up to full power on the broadband elements.
Can you explain how you accomplish 160 meters on that deal?
I did in the beginning. It's a terminated loop in a pennant configuration. And so what does happen is you don't have the efficiency of a full-size 160-meter antenna. But the advantages is that it is a terminated loop, so it's quiet, and you're up in the air a lot higher than you would normally be with your 160-meter antenna. Plus, because of the way we've got it set up in that pennant configuration, you have some nulls to the side of the antenna. So it acts like a rotatable dipole. So you have a little directivity with the antenna when you point it in the direction you want to talk. So if you hear someone on 80 meters like Bobby, whatever his name is, Bobby Ray, who's rag chewing forever, you can just rotate and you can't hear him anymore.
Yeah, Lloyd.
How long did it
Yeah.
take for him to put that antenna together at HRO?
That HRO antenna took me about 35 minutes to do.
Nice.
When we do the 40 meter when we did the antenna at Dayton, it took us about an hour or so because we had that big tower. Let me see if I can pull up a picture of that. We had that big tower assembly and all that, and we just, spacing wasn't right, so we had to kind of finagle things. But it took us about an hour and a half to set up the 40 meter. And what was really neat, think about this, guys. We set the 40 meter hex beam up on top of the 60-foot crank up. Well, actually, it was about 60 feet when it was all over and done with. We did no real tuning. We hooked it right up to the amplifiers. We did do some checking, and we were below 1.5 to 1 on 17 meters, on 20 meters, and on 40 meters. And that was right out of the box without having to mess with it. And that was in a really nasty environment. And Dayton can be pretty rough when it comes to HRF and all that neat stuff.
Well, given the fact that it's light, easy to put together, have you had any of these go out on e-expeditions at all?
Oh yeah. As a matter of fact, I took one out on myself to Dry Tortuga. We made matter of fact, we have another antenna that we specifically designed just for, let me see if I can find that.
You're not sharing your screen anymore.
No, I know, I'm trying to find it real quick and then I'm going to share it. No, special events, there we go. Okay, now I'm gonna share. Because that's just the way I am, guys. Okay. Okay, there you go. This is on the island of Dry Tortuga. This antenna was only 15 feet in the air, and we had absolutely terrible band conditions. I mean, it was, how do I say it? It was, well, let's just put it this way. It was terrible. This was the only antenna that was working for us, was our hexbeam. When it was all over and done with, we had a little over 2,300 Qs. We had two radios working on this antenna at the same time. Had we had the proper bandpass filter and 10 meters was working, we would have had, 3 radios working on the same antenna.
Wow, that's impressive. Any other questions from the group?
There's that's a big wide angle shot of everything. You see we had wind generators. This is funny. This wind generator right here we got from Amazon, and it's basically a Chinese import. It stopped working about 18 hours after we started using it. This wind generator we got, it's from Missouri Wind and Solar. It takes only about 8-mile-an-hour winds for it to start generating at least 2 to 3 amps of power. And then when you got up to 10 miles per hour, you're looking at 10 and almost 20 amps of power. So it literally, this one wind generator kept us running for the entire period that we were there. Plus we had a couple solar panels, but where we were really getting our power was from the wind generator. Then of course you can see the hex beam in the background. That's me right there with my bandana. That's HJ working, I think he's working RIDI, and I forget who's over here.
Cool.
And then we had, during field day, whoops. During field day, we had about 6 antennas out. We had two of them at ICOM, and they decided that they were just going to use a combiner. So what they ended up doing is they just used the triplexer with the bandpass filters, and they were able to run 20 meters, 15, and 10 when the bands allowed them to, which was really nice, working 3 radios off of one antenna. And then on the 40-meter hex beam, this is where things get really interesting. Because the 40-meter element is a separate feed, you can put in a radio on that one too with a bandpass filter. So now you've got 4 radios on one antenna. That kind of makes it kind of cool when it comes to a multiplier, when it comes to competitions or even expeditions. You point the antenna in the direction you want to go, and then you operate on the frequency, providing you have the right combiner and the bandpass filters.
I was wondering who controls the rotor.
Where do you get the bandpass?
Yeah, it's called straight.
Where do you get the bandpass
Yeah, we
filters
did.
from?
We got originally we got it from Dunstar, but ever since Dayton we've been using Array Solutions.
Awesome. Any other questions?
Dunstar,
All
go
right.
ahead. Yeah, Dunstar makes a good combiner, by the way. It's a good general purpose, very durable combiner. It is set only for 20, 15, and 10. So if you have any aspirations of running 17 and 20, it's not going to happen. You're going to have to make your own combiner.
All right, Emmett, thank you so much. We're going to move on with our regular meeting at this point, but boy, that was
All right.
a great presentation, and again, I'm a firm believer, even though I don't have one presently, but I'm trying to talk people into getting them, one particular person in particular, but I think
Well,
they're excellent antennas.
Rochelle did tell me that for the club purchases, if you can get at least 3 or more people, she'll have some special pricing for the club.
All right, excellent, excellent. In spite of Teddy and Ray then, right? Even in spite of them.
Yeah.
All right. Very good. Thanks, Emmett. Appreciate it.
All right.